In the beginning, there was only darkness, an infinite void that stretched beyond comprehension, where no stars had yet burned. This vast emptiness, stretching across the unfathomable depths of space, held within it all the potential of the universe to come. Then, a moment of unimaginable intensity occurred. A singularity, a point of infinite density, erupted in a violent explosion that would come to be known as the Big Bang. It was from this moment, about 13.8 billion years ago, that everything we know, the matter, the energy, the very fabric of space and time itself, emerged. In a fraction of a second, the universe began to expand, cooling and spreading, creating the foundations for all that would come after. Within this newly created universe, hydrogen and helium, the simplest and most abundant elements, began to form, the first building blocks for stars and galaxies. But what would become of this primordial soup? What path would this new universe take? From this formless sea of particles would arise something beautiful, intricate, and vast: galaxies. From the remnants of the Big Bang, over millions of years, the universe began to cool, allowing matter to clump together. As gravity pulled gas clouds closer, dense pockets of hydrogen gathered, collapsing under their own weight. And from this collapse, stars were born. The first stars in the universe were massive, burning with a fierce heat and emitting energy that shaped the course of cosmic history. These stars, ancient beacons in an infant universe, were the catalyst for the next phase of cosmic evolution. They forged the heavier elements we are familiar with: oxygen, carbon, and iron, through nuclear fusion. These elements, the building blocks for life as we know it, were scattered across the cosmos when these first stars exploded in supernovae, seeding the universe with the very matter that would eventually form planets and life itself. The first galaxies began to take shape around these young stars, chaotic collections of gas and stars, some small and irregular, others swirling into spiral forms. These galaxies would set the stage for the complex cosmic networks we see today. The universe was not a quiet place. In these early eons, galaxies were not isolated, still worlds. They were vibrant, pulsating bodies, forever changing. As time passed, galaxies began to grow, not in isolation, but through violent cosmic collisions. Gravitational forces, the invisible pull between massive objects, brought galaxies together, often in catastrophic mergers. These galactic mergers were more than just violent encounters. They were the engines of cosmic evolution. As galaxies collided, clouds of gas and dust were compressed, sparking waves of new star formation. These collisions transformed the very structure of the galaxies involved. Some galaxies became larger elliptical shapes, their stars scattered in loose orbits, while others, like our Milky Way, formed into spiral shapes, their stars arranged in vast, sweeping arms. These mergers also produced gravitational waves, ripples in the fabric of space-time, that continue to echo through the universe today. Even in the chaos, the universe was creating new worlds, new stars, and new potential. The force of these collisions could also trigger the birth of supermassive black holes at the centers of galaxies, adding another layer of mystery to the already complex process of galactic evolution. As these galactic mergers unfolded across the universe, some galaxies, like our own Milky Way, found themselves settling into a more stable, spiral form. The Milky Way, a stunning spiral galaxy, is a dynamic and ever-evolving system, a place of birth, destruction, and rebirth. It is not just an island of stars, but a cosmic ecosystem where stars live and die, where new stars form, and where ancient ones fade into the abyss. The Milky Way is part of a vast cosmic web, a network of galaxies bound together by gravity. It is not alone in this web. Surrounding it is the Andromeda Galaxy, a massive neighbor, and together, they are on a collision course. In about 4.5 billion years, the two will collide, merging into a single, larger galaxy. This will be a spectacular, cataclysmic event, a true cosmic dance, and yet, from the destruction of both, new stars will form. This dance of galaxies is not an isolated phenomenon. It is the very fabric of the universe at work, constantly shaping and reshaping the stars and galaxies within it. The cosmic ebb and flow of creation and destruction is a story that has no end, only evolution. At the heart of many galaxies, including our own, lies a supermassive black hole, an enigmatic and powerful force that shapes the very destiny of the galaxy. These black holes, with masses millions or even billions of times that of our Sun, have an immense gravitational pull, affecting everything around them. Their very existence raises profound questions about the nature of the universe. How do they form? And what role do they play in the larger workings of galaxies? As material, gas, stars, and even other galaxies spirals into the black hole, it heats up, emitting radiation that can influence the galaxy itself. In some cases, this energy can trigger bursts of star formation, creating new life in the galaxy's heart. In other instances, the black hole can stifle the formation of new stars, effectively choking the galaxy's growth. The relationship between galaxies and their supermassive black holes is complex, a dance of creation and destruction, where the black hole may hold the galaxy's future in its grasp. Are they symbiotic partners in the universe's evolution? Or is the black hole simply the silent, destructive force at the core of the galaxy's fate? Over billions of years, the cosmos itself grows older, and galaxies too undergo inevitable transformations. As galaxies age, they begin to exhaust their fuel, the gas needed to create new stars. The once vibrant cosmic neighborhoods now grow quieter as fewer stars are born. The galaxies grow old, their stars becoming red giants, burning through their fuel at an increasingly slow rate. The once active regions of star formation fade away, replaced by vast stretches of space with little new growth. This is the twilight of galaxies, where the once glorious spiral arms become ghostly, and the brilliant stars that lit up their cores gradually fade into the dark. Galaxies like these are no longer the active, dynamic systems they once were. They are red and dead, their energy spent, leaving only faint traces of their once great glory in the cold expanse of space. This slow decline is inevitable, a reminder that all things in the universe, even galaxies, must eventually come to an end. Over unimaginable stretches of time, a galaxy that once teemed with life, the fiery birth of stars, the dance of cosmic forces, fades into the cold silence of the universe. The stars that once illuminated its expanse burn out, their energy exhausted. The remaining stars, old and faint, drift through space, slowly winding down like the final notes of a song. Eventually, the galaxy's gas is depleted, and with it, the possibility of new stars being born. The galaxy's once spiraling arms collapse, and it becomes a dull, elliptical remnant, a cosmic fossil of its former self. While the death of a galaxy might seem like an end, it is not a singular event. It is merely the natural conclusion of a long process, one that may take billions of years. But in the death of one galaxy, the universe continues to evolve, and new galaxies are born from the ashes of those that came before. This cycle of life and death is the eternal rhythm of the cosmos, where destruction and creation are forever intertwined. As the galaxies die, the universe itself continues to stretch outward, its expansion continuing into the great unknown. Some scientists speculate that this expansion will continue indefinitely, with galaxies drifting farther and farther apart, leaving behind an increasingly cold and empty universe. But even as galaxies vanish into the void, the energy of the universe endures. Dark energy, the mysterious force driving the expansion of space, continues to push the cosmos apart. Will the universe eventually reach a point where all that is left are cold, fading stars scattered across an ever-widening expanse? Or will new forces emerge, perhaps from the quantum fabric of space-time itself, to create new possibilities for the universe? The mysteries of cosmic evolution remain, and though galaxies may die, the universe will continue to evolve in ways that we can scarcely imagine. Perhaps the most humbling thought of all is that our own story, humanity's story, is but a brief moment in this grand cosmic narrative. We are but a fleeting spark in the vast, eternal darkness of the universe. And yet, even in this brief moment, we find meaning. As we look up at the stars, we peer into the past, tracing the light of ancient galaxies and the echoes of long-dead stars. The universe's evolution is not just a story of cosmic change, but a reminder of the mysteries that await us, mysteries we have yet to fully comprehend. The journey of the galaxies may one day come to an end, but the universe will continue, forever expanding, forever unfolding. And with each passing moment, we grow closer to understanding the profound depth of this incredible, ever-changing cosmos.